Warm up for lesson 3-8, solving systems of equation using inverse matrices. Pause to answer this question. And here's the answer. Pause to answer this question. Be careful with the order. It's matrix B times matrix A. And this is the answer. Lesson 3-8, solving systems of equation using inverse matrices. Objective, find the inverse of a 2x2 matrix, write and solve matrix equations for a system of equations. All right, let's take a look at identity and inverse matrix. First, let's take a look at the identity matrix. For a 2x2, the identity matrix looks like this. This diagonal is all ones, everything else is zeros. On a 3x3 matrix, this diagonal's ones and everything else is zero. Now in multiplication, the identity is, let's go ahead and talk about that. If I take 3 times 1, the answer is 3. This is the identity for multiplication. It doesn't change anything once I multiply. And that's what's happening over here. This is the identity matrix. When you multiply a matrix by the identity matrix, you just get this answer. And if you multiply the identity matrix first and then multiply it to this number, you still end up getting the same number. So the identity matrix, no matter whether you multiply it after or before, you're still going to get the same matrix. It doesn't change anything. All right, so to decide whether some things are inverses, if you multiply two matrices together and you get the identity matrix, then they must be inverses to each other. For example, let's decide whether these two are inverses to each other. What we're going to do is multiply them. We're going to take this column and we're going to multiply here. And we're going to get this -1 over here, +2, and the answer is 0. We're going to go through all the elements and we're going to find this. Now this is not an identity. Identities would have ones along this diagonal. So the conclusion is that these two matrices are not inverses. Now let's take a look at these two matrices. I'm going to multiply F times G. Remember, this whole row is multiplied to this whole column. I'll get this kind of product and difference here, and I'm going to get the 1 as an answer, and then I'm going to do the same thing over here. Now when I do all the multiplication, I am going to get the identity matrix. Now if I switch and multiply G times F, you should also get the identity matrix. So they're only inverses if you multiply them one way and then the opposite way, and you get the identity matrix. Okay, let's determine whether these are inverses of each other. So what I'm going to do is I'm going to multiply it. First I'm going to multiply x times y. So this is 4, -1, 2, -2. I'm going to multiply it to 1/3, 1/3, -1/6, -2/3. Okay, so I'm going to get this column, 4 times 1/3 plus, and then -1 times 1/3. Now I'm going to multiply this row times this column, and I'm going to get -4, 6. I'm going to multiply this, and that's plus 2/3. And then I'm going to multiply this with this column, so that's going to be 2/3 plus -2/3. And then I'm going to multiply this and this, so that's -2, 6 plus, now I'm going to multiply this, and then that's going to be +4 thirds. Okay, so let's see what happens. Now this is 4/3, and this is -1 and 1/3, multiplying them. So that's 4/3, take away 1/3, that'll be 3/3, so that is going to be a 1. I can see this is a 0. I can see this is 2/3, -2/3 plus 2/3, so that's a 0. And then this is a 1/3, So negative 1/3 plus 4/3 is going to be 3/3, and that is going to be a 1. So far, so good. In order to make sure that it's inverses, I would have to switch everything around and multiply again. And make sure this is true. And it will happen. Okay, so would you go ahead and pause and see if you can multiply these and determine whether they're inverses. And here's the answer. All right, the inverse of matrix A is this. So this is the formula that helps you determine the inverse matrix. All right, and so what we're doing is we're going to create a scalar. This is a number that's being multiplied to the matrix. We're going to multiply these two numbers right here and subtract the product of these two numbers, and that creates the scalar. Okay, now the matrix here is going to be these two trading places. These two will stay the same, but you'll have the opposite signs. And this is what we call the inverse matrix. Oh, by the way, this is important. This cannot be equal to 0 because you cannot divide by 0. If this happens to be 0, then we have no inverse matrix. All right, so let's go ahead and see if we can find the inverse matrix. First thing is, let's try to figure out the denominator, which is AD minus BC. So in this case, this is AD, which would be 7 times negative 1 minus, and then 2 times negative 5. So that answer is negative 7 plus 10, and that answer will be 3. So this scalar right here is going to be 1/3. All right, we're going to take these two and we're going to trade places, which it looks like is happening, and then we're going to take the opposite of 2. Let's see, opposite of 2 right here, and then the opposite of 5 right here. So these two have traded places, and these have changed their signs. So I'm going to take 1/3, and I'm going to use the distributive process, multiply 1/3 to each one of these, and then this is the answer I get, and this is what we call the inverse for this matrix. Okay, so let's try to find the matrix here, but don't start setting up until you figure out your denominator here. So AD minus BC. So you're going to multiply these two, and that's going to be 72, negative 72 minus, and then multiply these two, and that's going to be a negative 72. Two negatives in a row make a positive. That's equal to 0. That means this will be a 0, and so this does not have an inverse. No inverse, because the scalar part is going to be undefined. Okay, let's go ahead and find the inverse matrix. All right, so step 1 is to first figure out this scalar part. So I'm going to multiply these two, negative 12, minus, I'm going to multiply these two, and that's 7. So that answer is negative 19. So my scalar will be 1 over negative 19, and then the new matrix will be, remember, these two trade places, negative 4, 3, and then these change their sign, negative 1, negative 7. So the inverse matrix will be, now distribute, so that will be positive 4 over 19, positive 7 over 19, positive 1 over 19, and negative 3 over 19. And this is what we call the inverse matrix. If I were to take the original and multiply it to this, I would get the identity. Okay, let's go ahead and do this. I'm going to multiply these two, that's 6. Take away, and I multiply these two, and that's a negative 4. So that's going to be a 10. That's going to be my scalar, 1 over 10. And then I'm going to exchange places, 3 and 2, change the sign, 4 and negative 1. And then when I multiply out, I am going to get 3 over 10, negative 1 over 10, 4 over 10, which you can reduce to 2/5, and 2 over 10, which you can reduce to 1/5. and that is the inverse matrix. Okay, pause and see what you can do. And here's the answer. Okay, so why do we want to do inverse matrix? Well, it's going to help us solve this. We've already had this before. We've solved it with algebra. Now I'm going to show you how to solve it with matrices. So what we're going to do is we're going to take this portion right here and we're going to make it into a matrix, and we're going to make this part into a matrix. Now this matrix, what we're going to do is we're going to put the coefficients in A, and in X matrix we're just going to write X and Y. So when you multiply these two with this column, you create the X plus 2Y. If you take this row and multiply this column, you're going to create the 3x minus 6y. All right, now in algebra, when we want to get x by itself, we multiply by the reciprocal or the inverse. And what we want to do here is we want to multiply by the inverse as well here. Now be very careful to put the inverses in the front both times. Don't put the inverses in the back. Now when the inverse means I'm just going to get the identity, which is x, and then I'm going to get b over a as my answer. We're going to do the same thing. We're going to multiply this side by the inverse matrix and put this one in the front. Don't put it in the back. And then these two will create the identity matrix, so it'll just be x, and then we'll just find this answer, and we'll have the answer to what x is and what y is. Okay, so let's go ahead and do a problem. So here's the system. I am going to write the coefficients, which are here, and I'm going to write the variables here, and then these are the answers right here. I'm going to first do the scalar, which means I multiply these two, subtract these two. So in the end, this answer is going to be negative 0.25. So I'm going to write the scalar is 1 over negative 0.25. And then I'm going to figure out the inverse matrix, which means what I do is I trade places. So that's going to be 3.5, 1. And then I'm going to change these signs, negative 3.75 and negative 1. I'm going to do the same thing on this other side. And I'm going to write 3.5, negative 1, negative 3.751. Now I know that these two will create the identity matrix, so I'll just have 1, 0, 0, 1, and I know this won't do anything here. But right here, what I want to do is, I know this is going to be 1 divided by negative 0.25, and if you put that in the calculator, that's going to be negative 4. All right, and now I'm going to multiply this row with this column. So this is going to be 3.5 times, maybe I should erase this part right here. 3.5 times 24.2 plus negative 1 times 88.05. Now I'm going to take this row and I'm going to multiply it here, so it's negative 3.75 times 24.2 plus, and I multiplied these two, and now I need to multiply 1 times 88.05. So this is going to be, here's my scalar, and then I'm going to use my calculator to figure out that answer. This is a point. Okay, so that's 3.5 times 24.2, take away 88.05. Now I'm going to get a negative 3.35. Now I'm going to multiply these. Negative 3.75 times 24.2 plus 88.05, and I'm going to get negative 2.4. I still need to multiply by my scalars. So negative 3.35 times negative 4, and I'm going to get 13.4, and now I'm going to take negative 4 times negative 2.4, and I'm going to get 9.6. Now this tells me what x and y are. So x is going to be equal to this, so x is equal to 13.4, and y will be equal to this, y equals to 9.6. All right, go ahead and pause and see what you can do. And here's the answer. Again, I made the, here is the coefficients right here. Here's x over y, and here's the answer. So I took this and I tried to find the inverse right here, and I went ahead and put it in the front and went ahead and solved, and when I got x equal to 2 and y equal to negative 4. Okay, let's take a look and pause and see if you can figure out who's correct. And here's the Cody is the one who has the error. This represents our x, and this represents our x, which is not true. Our x should have been a 4.